What if a comet that once passed through our skies was not only a fragment of ice and dust, but also a quiet note from somewhere far beyond, a trace of a journey written in silence rather than in words? We can begin with this thought gently, without insisting on an answer, just letting it rest beside us. The comet known as 3I Atlas appeared briefly, faint and fragile, and then it was gone. Its origin was interstellar, which simply means it did not belong to our solar system. It came from outside, carrying with it a history we cannot fully read. To imagine such a traveler is to imagine something unanchored, drifting for millions of years before brushing past our sun. The scales are almost beyond comprehension, yet we can soften them with familiar comparisons. Just as a bottle can float on an ocean current for decades, carrying traces of its origin, so too can a comet drift through the currents of interstellar space. Now let us pause on how such an object is noticed. Telescopes scan the sky and record tiny variations in light. A comet becomes visible not because it shines by itself, but because sunlight reflects from its dust and gas. When 3I Atlas was found, what we truly saw were changing dots of brightness plotted night after night. These dots told us where it was moving and how quickly, like following footsteps across a beach at dusk. The mechanism is simple in essence, but in practice full of uncertainties. We measure faint light across vast distances through air that blurs and instruments that have limits. It is a little like trying to judge the shape of a leaf floating far out on a pond, seen only through ripples. Still, from such fragments we construct paths, orbits, and estimates. And yet, absence of detail remains. We cannot know exactly what its surface looked like, nor what mixture of ice and rock it contained, because it broke apart before close study. What we have instead is the language of traces. In science, traces can be numbers in an archive, particles in a detector, or patterns across a graph. With 3I Atlas, the traces are its brightness curves, its orbital parameters, and the timing of its disintegration. They are indirect, like shadows on a wall, telling us that something passed by even after it is gone. Now, if we let ourselves drift into a small thought experiment, we might imagine that this comet carried a kind of message. Not a message in words, but perhaps in its very presence. Step 1. It journeys for millions of years, undirected yet persistent, through the deep quiet of space. Step 2. It arrives in a system where beings are watching, and for a brief moment it becomes visible, leaving behind data points on screens, lines in notebooks, memories and human minds. Step 3. Long after it fragments and disappears, the records remain, and generations later they may still be studied, reinterpreted, reframed. In this way, the comet becomes a messenger not by intention, but by endurance. Of course, we must remain careful. There is no evidence that 3I Atlas carried any deliberate signal. Its fragmentation suggests fragility rather than design. But the absence of evidence is not the same as evidence of absence. We simply do not know, and that unknowing itself is instructive. It reminds us that the universe is vast, our tools are limited, and our interpretations always provisional. To rest with that uncertainty is to accept the quiet rhythm of science itself. If there is a warning here, it may not be written by others, but by our own reflections. We are the ones asking what such an object means, and in our asking, we reveal our own concerns about survival, future, and connection. Perhaps that is the most enduring message, not what the comet carried, but what it stirred in us. And so we let the thoughts settle softly, like dust slowly sinking through water, leaving gentle ripples behind. What if a small, fragile body drifting through the darkness is not just a piece of ice and stone, but a reminder that the universe is larger than any map we have drawn? When we speak of 3I Atlas, we are speaking of something that came from beyond our own solar neighborhood, carrying with it a path that began far away, in regions we cannot yet picture with clarity. To call it interstellar is to say it was not born under the pull of our sun.
It was not shaped by the same cycles that guide our familiar planets and comets. Instead, it arrived as a visitor, following a line of motion that does not close back into a loop, but continues outward, as if written with a single stroke across the page of the sky. Now let us gently rest with what that means. In our everyday lives, most things move in cycles: the rising and setting of the sun, the repetition of seasons, the return of habits. In space, too, most comets we know belong to cycles, their orbits bringing them back after long intervals. But 3I Atlas does not return. Its trajectory is what astronomers call hyperbolic, which simply means open, like a path that stretches without end. If we imagine throwing a stone with just enough speed to escape Earth's gravity, the stone will not come back. It will drift away, pulled no longer into circles, but into departure. This is the kind of path 3I Atlas followed, but on the scale of stars, not planets. To understand this more deeply, we pause on the mechanisms. A comet forms as a mixture of ice, rock, and dust, usually in the colder outer regions of a star system. When disturbed, it begins to travel inward, sunlight heating its surface, releasing gas and dust that form a glowing tail. With an interstellar comet, the difference lies in origin. It was not disturbed from our distant Oort cloud, but from another star's distant reservoir. Perhaps it was nudged by the gravity of a passing body, perhaps expelled during the early days of another system's formation. We cannot trace back exactly which one, for space is vast and the paths blur over time. What we can do is follow the traces left behind during its brief visit near us. These traces are subtle. The brightness of its coma, the timing of its fragmentation, the shape of its orbit as recorded through many nights of observation. All of these become entries in an archive, stored as numbers and graphs. They are like pressed leaves kept in a book, fragile, flattened, yet still enough to remind us of a living form that once moved and changed. Still, we must acknowledge the limits. Our instruments saw only faint signals. The comet disintegrated before we could observe it closely. We cannot know its full composition, nor the exact details of its structure. The lack of material left to study means much of our knowledge is inference, careful but incomplete. It is a reminder that absence itself is a form of data. The fact that it broke apart tells us something about its fragility, even if not about its origin. Let us imagine, softly, a small experiment of thought. Step 1. A comet like 3I Atlas is born in a young star system, billions of years ago. It is cast outward, perhaps by a gravitational encounter, and begins a long, slow drift between the stars. Step 2. After millions upon millions of years, it enters our solar system by chance, a brief crossing in an endless night. We detect it, measure it, give it a name, and wonder about it. Step 3. After its departure, it continues outward, perhaps one day passing through another system, where other observers may also watch and record. In this way, the comet becomes a kind of shared marker, not by intention, but by endurance, a thread linking distant beings across time. We cannot prove this, but the possibility itself has a quiet weight. Now we pause to reflect on the indirect language of evidence. For most of the universe, we do not see things directly. We see how they affect light, how they leave imprints, how they disturb patterns. With 3I Atlas, we saw a faint brightening against the background of stars. We plotted positions, noticing the shape of a path that could not be bound by the sun. From these small signals, we understood it came from beyond. It is as if we noticed a footprint that did not match any of the familiar shoes in our household. We know a stranger passed, even if we never saw them. The message here is not certainty, but presence. We know it was real. We know it was different, but the meaning of that difference remains open. Was it one of many, or one of few?
Are such visitors rare, or simply rarely noticed? We cannot yet say. What endures is the trace in our records, the data stored in archives, waiting to be revisited as new questions arise. And so, the nature of 3I Atlas is not only in its fragile body, now scattered, but in the shift it brought to our perspective. It reminded us that the solar system is not closed, not isolated, but part of a larger stream where objects wander from one domain to another. It is a reminder written in motion rather than words, a quiet gesture across the stars. We leave this thought not with conclusions, but with openness, letting the uncertainty rest like a gentle pause before the next breath. What if what remains of a celestial visitor is not its body, but only the faint traces of its passing, a record that is more absence than presence? With 3I Atlas, this is what happened. The comet broke apart before it could be observed in detail, leaving us with fragments too small and too faint to follow. Its physical form is gone, yet in another sense, it still lingers, stored in curves of light measurements, in the subtle marks that remain in scientific archives. We find ourselves here at the edge of what is knowable, looking not at an object, but at its shadow. To understand this gently, let us pause on what fragmentation means. A comet is held together by fragile bonds of ice and dust. When warmed by the sun, the ice sublimates, turns directly into gas, and pressure builds within. Cracks form, pieces separate, and the comet may fall apart completely. In the case of 3I Atlas, this happened before it reached its closest distance to the sun. Instead of a solid body, we were left with diffuse clouds of debris. In everyday terms, it is like a snowball carried into a warm room. It does not melt evenly. It cracks, collapses, and dissolves into scattered drops. What remains is no longer the same shape, but the water still tells us where it came from. Now we rest for a moment with the limits of such evidence. Without the intact comet, we cannot collect direct samples, cannot send instruments to touch its surface, cannot weigh or map it with precision. What we know comes instead from telescopes watching the brightness fade. As the pieces spread, the light became diffuse, harder to measure, until even that disappeared into the background of the sky. What remains is an archive of numbers, brightness over time, positions across nights, the timing of its sudden dimming. These records are like the log of a heartbeat that stops. The lines end abruptly, but still show the rhythm that came before. This is the language of traces. Science often works not with objects themselves, but with the patterns they leave behind. Tree rings are not the tree itself, but they tell us of its growth. Ice cores are not the air itself, but they hold bubbles that whisper of climates long gone. In the same way, the loss of 3I Atlas leaves behind an indirect archive. It is quieter, harder to read, but still it speaks. Let us drift now into a gentle thought experiment. Imagine, step 1, a comet approaches, carrying with it secrets of another star system. Its structure is delicate, and as it nears the sun, it fragments. Step 2, fragments disperse, carried along its hyperbolic path. Some pieces may remain for centuries, wandering unseen or falling into dust too fine to trace. Step 3. Though the body is gone, records remain in human archives. And in those records, the comet continues to exist, waiting to be re-examined by later generations. The comet has dissolved, yet its memory remains alive, not in ice, but in data. We pause here to notice the humility of this position. We cannot claim knowledge we do not have. We cannot know its exact mass, nor the full list of its components. What we can do is hold carefully what the traces reveal: that it fragmented earlier than expected, that it was fragile, that its brightness followed patterns consistent with ices like those of other comets. We can compare, but not conclude. And this restraint is itself important, reminding us that absence of direct evidence does not erase
Possibility of meaning. Before we move on, let us mark one more layer. The fragmentation itself is a kind of signal. It tells us something about the forces at play, about the materials inside, about the stresses that act on such travelers. Even the way it failed becomes data. In a sense, the breaking apart was the comet's last message, written not in words, but in the fading curve of its light. If we listen gently, we can hear the echo of that message in the archives, quiet but enduring. What remains then is not emptiness, but a different kind of presence, a presence of records, of traces, of curiosity kept alive.
And as we let this thought settle, we understand that sometimes the absence of an object is what draws us closer to its story, inviting us to imagine carefully what once was and what may still drift unseen in the dark. What if a comet is not simply a fragment of ice and rock drifting through space, but also a kind of archive, a record that carries across time without words or intention? When we think of messages, our minds turn to letters, voices, signals sent by design. Yet the universe often preserves information in quieter ways. A fossil in stone is a memory of a living form. A bubble trapped in ice is a memory of ancient air. A comet, too, can be seen as a kind of storage, a capsule that keeps the chemistry of its birth and the trajectory of its journey. Now let us pause gently and rest on the scales of space and time in which this idea unfolds. A comet may travel for millions or billions of years, moving from one star system to another, untouched, unaltered except by slow erosion. Its body contains molecules that may have been present when its parent star was young. To hold such material is to hold a fragment of deep history, one that stretches beyond human memory, beyond the history of Earth itself. In this sense, a comet can be thought of as an accidental messenger, carrying not words but chemistry, structure, and path. To understand this more softly, we can think of a comet's composition. Inside, it is a mixture of frozen gases, dust, and minerals. Scientists sometimes call it a dirty snowball, a simple image that conveys both fragility and richness. As it warms near a star, the frozen gases evaporate, forming a glowing tail. This release is not only beautiful, it also reveals what lies within. By studying the light from this tail, astronomers can learn which molecules are present. In that light, the comet speaks in its own language, not with sound, but with spectra, patterns of color that act as signatures of materials. But there are limits. We cannot always collect enough data before the comet fades or fragments. Instruments have their thresholds. Distance blurs clarity. What remains are partial readings, incomplete lists of molecules, curves of brightness without the full picture. This incompleteness is important, reminding us again that absence of evidence does not equal evidence of absence. The language of traces is subtle. Still, even these fragments carry meaning. We record them in archives, compare them across comets, and notice patterns. Some contain organic molecules, simple building blocks of life. Others reveal unusual isotopes, variations of elements that tell us about the environment in which the comet formed. Each piece is like a page in a book where most words are missing, but enough remain to hint at a story. Now we may let ourselves drift into a thought experiment. Step 1. Imagine a comet forming in a distant system, capturing within it ice and dust from that time and place. Step 2. After millions of years, gravitational nudges send it outward, across the void, until it passes near another star, ours. Step 3. Beings living there notice it, record its light, and decades later still reflect on its traces. The comet, without intention, becomes a messenger across time and space, not because it carried meaning, but because others found meaning in what it preserved. Here we can pause to see how such ideas connect to archives we already know. Tree rings remember droughts. Sediment layers remember floods. The very crust of Earth remembers impacts from long ago. None of these were deliberate messages, but all of them are records. A comet is simply another layer in this vast archive, moving instead of resting, but carrying the same quiet persistence. We do not need to imagine signals to recognize this. The message is not necessarily what was sent, but what can be read. And yet, we must hold the uncertainty. We cannot know how complete our readings are. We cannot claim that one comet tells the whole story of its origin. We can only say that each one adds to the larger mosaic, a picture assembled slowly, piece by piece, over generations. In this way, the comet becomes part of a collective language, its traces woven into the broader archive of the cosmos. And so, as we let this thought settle, we see that a comet may indeed be a kind of message, though not in the way we first imagine. It may be a message written in chemistry, in orbit, in the fact of its survival across such vast spans of time. Whether we call it a warning, a gift, or simply a trace, it reminds us that the universe has its own ways of keeping memory. We do not need to decide what the message means now. It is enough to notice that it exists and to allow the quiet possibility to remain, like a soft echo lingering after the sound has faded. What if the meaning we attach to a comet tells us more about ourselves than about the object itself, as though the sky were a mirror reflecting our own questions? When 3I Atlas appeared, we could not help but wonder whether it carried a warning, or whether it was simply another fragment of ice and dust passing unnoticed through space. This act of interpretation is deeply human. We are shaped to find patterns, to see faces in clouds, constellations in stars, messages in the movements of the heavens. It is not proof of anything beyond us, but it is proof of how we connect, how we long to make sense of the unfamiliar. Now we can pause and rest with the scale of this tendency. Across centuries and cultures, comets have carried meaning. Ancient chronicles describe them as omens of change, sometimes feared, sometimes welcomed. In those times, observation was woven with myth. Today, we observe with instruments, and yet the impulse is the same, to ask not only what the comet is, but what it might mean. The context has shifted, but the underlying desire remains. Let us consider the mechanism of this process in gentle terms. When something rare appears, our attention sharpens. The mind seeks cause, seeks connection, weaving narratives from fragments. Psychologists sometimes call this pattern-making a cognitive bias, but it is also a survival tool. To notice shapes and shadows might have once saved lives. In the cosmos, it turns into stories of signs and warnings. The comet itself does not change, but our interpretation wraps around it like mist around a mountain. We must acknowledge the limits of such interpretations. We cannot know whether 3I Atlas had meaning beyond its own physics. We cannot prove intention, nor rule it out entirely. Our tools measure orbits, brightness, spectra of light. They do not measure purpose. And so we stay in a space of uncertainty, where the absence of evidence is not the same as evidence of absence. In this space, we tread carefully, letting possibilities remain open without grasping at certainties. Now let us notice the language of traces here. The traces are not only in data and archives, but also in ourselves. Cultural records, stories, articles, the very fact that we are reflecting now, all of these are markers left behind by the comet's brief visit. In a way, 3I Atlas wrote itself into human history not by what it was, but by what it inspired us to think. The trace lies in questions rather than answers. If we imagine softly a sequence of thought, it might unfold like this. Step 1. An object appears in the sky, fragile and fleeting, and astronomers measure its path. Step 2. People beyond the scientific community begin to wonder, to interpret, to attach meaning. Step 3. Those interpretations linger long after.
Comet itself has gone, becoming part of culture, memory, and perhaps even guiding how future visitors will be perceived. In this sense, the comet is not only a physical body, but also a catalyst for reflection, a quiet spark that reshapes human thought. Now we rest a moment with the humility this invites. The universe may not be sending us messages, and yet we keep asking. This act of questioning is itself significant. It shows that we are attentive, that we notice rare events, that we seek to place ourselves in a larger context. Whether or not 3I Atlas was a warning, the very idea of warning reveals something about our concerns. We worry about survival, about the fragility of our place, about the possibility of futures not yet written. These worries become projected onto the comet, and in that projection, the comet becomes a mirror. A mirror does not generate images, it reflects them, and so too does the sky. Before moving on, let us pause with one last layer. The absence of clear answers can itself be calming. It frees us from the urgency of finality, allowing us to stay in the rhythm of wondering. In this rhythm, we learn that interpretation is not only about truth, but also about process. It is about how we carry questions, how we let them shape our awareness.
And so the comet remains with us, not as a solved mystery, but as an open reflection. A reminder that sometimes the meanings we find in the stars are quiet signals of who we are here on Earth. What if the true meaning of a comet lies not in its body, but in the pattern it breaks, the way it does not fit into the rhythm we expect? Most comets we know follow cycles. They belong to our solar system, bound by the sun's gravity, returning after long intervals. Some take decades, others millennia, but still they come back, carrying with them a sense of repetition, a reminder of cycles larger than our lives. An interstellar comet like 3I Atlas moves differently. Its orbit is not closed. It enters, it passes, and it continues outward, never to return. The shape of this path is called hyperbolic. In simple words, it is open-ended, like a curve that begins near and then drifts away without turning back. Now we can pause gently to notice why this matters. Cycles give us comfort. They allow prediction. We know when seasons will change, when tides will rise, when familiar comets will reappear. When something breaks this pattern, it stands out. Rarity itself becomes a kind of signal. It is as if we had grown used to a steady rhythm and suddenly heard a note that did not fit the song. The difference draws attention, invites us to look closer. Let us rest for a moment on how astronomers notice such patterns. They measure positions of objects night by night, plotting curves across the sky. When the path of a comet does not close back around the sun, when calculations show it will continue outward, they know it is interstellar. The process is mathematical, yet the effect is poetic. A single line drawn once across the solar system, leaving behind only records. But we must be careful. Not every open path is easy to confirm. Small errors in measurement, faint signals at great distance, can blur the distinction between a very stretched orbit and one that is truly hyperbolic. This is why we speak with caution. The absence of certainty does not mean the absence of reality. It means we must hold our conclusions lightly, knowing that some may shift as more data arrives. Now let us turn to the language of traces. The uniqueness of such an orbit is itself a trace. It is recorded in observatory logs, in archived data, in graphs that future researchers may revisit. The statistical rarity is another trace. Most known comets belong to cycles. Only a few follow hyperbolic paths. Over time, if more interstellar objects are discovered, the statistics themselves may change, and the traces will become part of a larger pattern. For now, each stands as an exception, a point of contrast against the familiar background. We can imagine, gently, a thought experiment. Step 1. Imagine our records continue for centuries, and many comets are logged, most repeating.
Some not. Step 2. Patterns emerge. We see that interstellar visitors are not impossibly rare, only difficult to notice. Step 3. The story of the solar system changes. We no longer think of it as a closed garden, but as a crossroads where travelers from other stars pass now and then. This shift would not be dramatic, but gradual, a quiet unfolding as the archive grows thicker. Now we pause again to notice how such a change affects our sense of scale. A repeating comet is like a returning friend. An interstellar one is like a stranger passing by, leaving only a fleeting impression. Both are part of the larger whole, yet the stranger reminds us that we are not isolated, that our sky is part of a wider network. It does not prove intention, it does not prove message, but it carries a quiet weight simply in its rarity. And so, we are left with the thought that patterns matter. The breaking of a cycle can be as meaningful as the cycle itself. What we notice in 3I Atlas is not only its fragility, but its difference, its refusal to return. In that refusal lies the gentle signal that the universe is larger than repetition, larger than our expectations. We let this realization rest without conclusion, a soft pause, like listening to a note that fades into silence but still lingers in memory. What if the arrival of 3I Atlas is not an isolated story, but part of a quiet sequence, a pattern that begins to show itself only when we look across decades? Before this comet, another interstellar traveler passed through our solar system, the object called Oumuamua. each was different. Oumuamua looked more like an elongated fragment, perhaps of rock, with no visible tail, while 3I Atlas behaved more like a traditional comet, brightening and then fragmenting. Together, they form a pair, rare visitors that suggest the possibility of more. When we rest with this thought, we notice how one event can feel extraordinary, but two begin to hint at a trend. Now let us pause to place this in context. Our instruments have been watching the sky carefully for only a short time compared to cosmic scales. For centuries, comets known to us were those bound to the sun, repeating in cycles. Only recently have telescopes become sensitive enough to notice faint bodies crossing from far beyond. This means that what seems like rarity might also be a question of detection. Perhaps interstellar visitors have always passed, quietly, unrecognized. Or perhaps their appearance is truly uncommon. We cannot yet distinguish between these possibilities. The mechanism of noticing is simple in principle, though delicate in practice. We track the paths of objects against the stars. If the orbit is closed, we know it belongs here. If it is open, hyperbolic, we suspect it came from elsewhere. With Oumuamua and 3I Atlas, the data showed open paths. This is the mark of interstellar origin, a signature written not in chemistry, but in trajectory. The absence of return is itself the evidence. Yet we must acknowledge limits. Measurements are never perfect. For Oumuamua, brightness was faint, and its shape only inferred from changing light curves. For 3I Atlas, fragmentation removed much of what could be observed. Our knowledge rests on partial glimpses, stitched together from imperfect records. Absence of detail does not mean absence of truth, but it asks us to remain cautious. Let us pause now on the language of traces. Each of these visitors left behind not their bodies, but their records. For Oumuamua, the trace is in the unusual light curve, archived in scientific papers. For 3I Atlas, it is in brightness measurements, fragments of orbit, and the memory of its sudden dissolution. Together, these traces accumulate, forming an archive larger than any single object. In time, this archive may reveal patterns we cannot yet see. We may imagine gently a small sequence of thought. Step 1. Today, only 2 interstellar objects have been confirmed, both within a short span of years. Step 2. In decades ahead, more sensitive surveys scan the skies, and more are found. Step 3. Patterns emerge.
Perhaps of frequency, perhaps of origin, perhaps even of composition. What feels now like exception may one day become a category, a recognized population of travelers across the stars. Before we move on, we can note that such a change would not be dramatic, but quiet, gradual. A shift in perspective, from thinking of these visitors as singular anomalies to thinking of them as part of the wider fabric of the universe. In this sense, the story of 3I Atlas is less about one comet and more about the opening of a window, a hint that the solar system is not a closed system, but a place where paths from elsewhere occasionally cross. And so, we are left with an open thought. Each rare visitor adds weight to the possibility that we are part of a larger flow, a slow traffic of fragments moving between stars. We cannot yet know the frequency or meaning, but we can rest in the knowledge that rarity itself is a marker. The exceptions remind us that the universe is wider than what we expect, and that the archive of the sky is still being written, line by line, across centuries. What if the limits of what we know about a comet are not weaknesses, but reminders of the delicate balance between clarity and mystery? With 3I Atlas, our view was partial from the beginning. It was faint, fragile, and visible for only a short span of time. We traced its light, measured its orbit, watched it fragment, and then it was gone. The gaps are wide, yet those very gaps are what shape our understanding. They remind us that every observation is filtered through distance, through atmosphere, through the sensitivity of our instruments. Now we can pause and gently notice how these tools work. A telescope is like an extension of the eye, designed to collect more light. The larger the mirror or lens, the more faint signals it can capture. But even the most powerful instruments must work with what reaches them. Light that has traveled for millions of years can be blurred by Earth's air, scattered by dust, or lost in background noise. Measurements are not absolute.
They carry uncertainty, ranges, margins. Just as we might weigh a grain of sand on a simple scale and know it is approximate, so too with celestial bodies. We know their mass and size within limits, never with perfect precision. This means that what we see is always layered with caution. We can say a comet likely contains certain molecules, but not confirm every detail. We can chart its orbit with confidence, but small variations remain. These uncertainties are not failures. They are markers of how knowledge is built, carefully, tentatively, with awareness of what may still change. Now let us rest with the language of traces. Even uncertainty leaves its own archive. Observations are logged, each with error bars, each with notes of confidence. Later researchers can return, compare, adjust with better tools, reinterpret in light of new findings. In this way, the trace of 3I Atlas is not just the data itself, but the uncertainty attached to it. The gaps become part of the record, shaping how future generations may read it. We may imagine softly a sequence of thought. Step 1. Today we have limited data, incomplete and scattered. Step 2. Decades later, with more interstellar comets observed, we compare, finding patterns that make sense of what once seemed unclear. Step 3. Centuries later, archives are vast, and what was once a fragment becomes part of a coherent whole. The gaps are filled not by one object, but by accumulation across many. This thought experiment shows us how uncertainty can transform into clarity over time, not through one moment, but through patience. Before we move further, let us pause on why limits matter. Without acknowledging them, we risk illusion of certainty. With them, we gain humility. We learn to rest in possibility, to accept that our picture is not complete. This acceptance is not resignation, but openness. It allows for growth, for surprise, for shifts in understanding. It is a quiet reminder that knowledge is a process, not a destination. Now,
return to the comet itself. Its traces are faint, its body dissolved, its path already beyond reach. Yet the very limits of what we know invite us to listen more carefully to what remains. The faintness is itself a marker of fragility. The fragmentation is itself a message about its nature. The gaps are not silence, they are part of the story. And so, in this space of limits, we find meaning. Not definitive, not final, but enough to keep the question alive. We let it rest here, softly, like a half-heard melody that lingers in memory long after the sound itself has faded. What if a comet's journey is less about its brief moment in our sky and more about the vast timescales it silently carries within? When we think of 3I Atlas, we are reminded that such an object may have been traveling for millions, perhaps billions of years before arriving here. Its path is shaped not by one system, but by many influences, spread across expanses that dwarf the span of human history. In this sense, a comet is not only a body of ice and dust, but also a witness of time far greater than our own. Now let us pause with the scale. On Earth, we measure time in days and seasons, in years and generations. A comet's timescale is different. It can wander between stars for epochs, drifting slowly yet persistently. Its presence near us is only a brief intersection, a passing instant against the background of cosmic time. To imagine this is to imagine a river flowing so slowly that entire civilizations rise and fall before one bend in its course is reached. The mechanism of such journeys is gentle but vast. When a comet is nudged out of its home system by the pull of a planet or the passing of a star, it begins an unbound path. Without strong gravity to capture it, the comet drifts into interstellar space. There, nothing hurries it. The distances are so wide that collisions are rare, and so it endures, a fragment of frozen history moving steadily through the dark. By the time it arrives in another system, its surface may have changed, but its core still holds the signature of its birth. Yet here we must acknowledge limits. We cannot track back its entire route. The gravitational poles along the way blur the trail. We cannot name the star where it began, nor the exact moment it was cast outward. Our records show only the curve of its final approach and departure. Beyond that, the details dissolve into uncertainty. The absence of certainty, however, does not erase the story. It only means the story is incomplete. Now let us rest with the language of traces.
The traces of time are held not in words, but in isotopes, in ratios of elements locked into the comet's ices, in the erosion on its surface. Scientists can, in principle, read such traces if fragments are captured, just as geologists read the age of rocks through layers and compositions. In archives of observation, time leaves other traces: how quickly the comet brightened, how it broke apart, how its orbit curved in ways only possible for an interstellar visitor. These records are layered like tree rings, small but enduring. We may imagine gently a thought experiment. Step 1. A comet forms in the outer reaches of a young star system, storing within it the chemistry of its time. Step 2. Billions of years pass, during which civilizations rise and vanish on distant planets, while the comet continues, unchanged in its core. Step 3. At last it crosses into another system, observed briefly, measured, and then let go again, continuing outward. The comet becomes a messenger of duration, carrying the weight of time itself. Before moving on, we can pause on how this perspective reshapes us. To consider a comet in such timescales is to see our own existence as brief. Our cities, our records, even our species are fleeting beside the journeys of these small icy travelers. This need not be unsettling. It can be calming, a reminder that the universe moves with patience, that survival can take many forms, some measured not in centuries, but in billions of years. And so we are left with the thought that 3I Atlas was more than an object. It was a passing marker of deep time. Its path tells us that
The universe is not static, that fragments wander, carrying with them the memory of distant beginnings. We cannot know every detail of its origin or path, but we can rest with the awareness that in its brief visit, it connected us, however lightly, to the immense currents of time that flow far beyond our own. What if the warning we imagine in a comet is not a deliberate sign, but part of a much larger language already spoken by nature itself? Earth holds many records of past events, quiet reminders that time leaves traces even when no one intended them. In tree rings, we find the memory of droughts. In layers of ice, we find the breath of ancient air. In rocks, we see marks left by falling asteroids. Each is a signal, not planned, but preserved, waiting to be read. When we place 3I Atlas into this family of signals, we begin to see that a comet may simply extend this natural archive into the interstellar. Now let us rest gently with the context of such warnings. Earth has endured impacts, extinctions, and shifts in climate. These events leave long-lasting evidence. For example, a thin layer of iridium in the rocks tells of a massive asteroid impact 66 million years ago, linked with the end of the age of dinosaurs. No one wrote this story, yet the Earth itself recorded it. In this way, a comet passing near us can be seen as part of the same system of reminders, not a message crafted for us, but a pattern that, if noticed, becomes meaningful. To understand this more softly, we pause on the mechanism of natural recording. A volcano erupts, and ash settles into layers of soil. A river floods, and sediments trap pollen and seeds. Later, we read these layers like pages in a book. Similarly, a comet's orbit, brightness, and chemistry are preserved in observatory archives. They become data points, marks of presence, even after the comet itself has gone. These are not deliberate warnings, but they function as signals if we know how to listen. Yet we must remain careful. Not every signal is easy to read, and not every pattern is clear. Sometimes layers are disturbed or data incomplete. Sometimes absence speaks as much as presence. The uncertainty does not erase the meaning, but it softens it, reminding us to hold our conclusions lightly. Now let us notice the language of traces more closely. For 3I Atlas, the trace is not only the path across the sky, but also the story of its fragility. Its disintegration before reaching the sun is itself a marker. It tells us something about the stresses comets endure, about their delicate structures, about the difficulty of survival even for bodies millions of years old. In archives of astronomy, these observations will remain, waiting to be compared with future visitors. The comet becomes part of a growing conversation, written in data, not words. We can imagine, gently, a thought experiment. Step 1. Comets like 3I Atlas continue to arrive, rarely but steadily, each leaving behind measurements and fragments of interpretation. Step 2. Over centuries, scientists collect these traces, assembling a picture of how interstellar travelers behave, what they carry, and how often they pass. Step 3. Patterns emerge, showing us whether such comets bring new chemistry, whether they pose risks, or whether they are simply markers of the larger flows of matter between stars. In this way, what began as a fragile visitor becomes part of a broader archive, a natural warning system that stretches across time. Before we move further, we can pause on how this shapes our perspective. The idea of a warning need not mean fear. A warning can be as gentle as the way the air cools before a storm, as subtle as the way shadows lengthen before night. It is not always a call to alarm, but sometimes a reminder to notice, to pay attention, to recognize patterns that extend beyond our immediate lives. And so we are left with an open thought. Perhaps 3I Atlas was not a message, not a deliberate warning from elsewhere. Yet in joining the long tradition of natural signals, layers, rings, isotopes, impacts,
reminds us that the universe is always leaving records. The warning, if there is one, may simply be to look, to remember that nothing passes without leaving a trace, and that these traces, carefully read, connect us to scales of time and space far greater than our own. We let this idea settle quietly, like dust in still air, a soft reminder of the continuity of signals all around us. What if the comfort of certainty is an illusion, and the real wisdom lies in accepting the soft edges of what we know? When we think of 3I Atlas, or of any interstellar visitor, we may feel the temptation to label, to decide quickly, it was only a natural fragment, or it was something more. Yet nature does not always give us answers in clear lines. Instead, it offers probabilities, possibilities, ranges of interpretation. Just as twilight is neither night nor day, but a blending, so too is our knowledge often a spectrum rather than a fixed point. Now we can pause and settle into the context. Astronomy has always lived in this space of in-between. The stars are far, and light is faint. Instruments give us clues, but never total pictures. Observers speak in terms like likely, consistent with, suggests. These words are not weakness, but honesty. They remind us that knowledge is built layer by layer, never absolute, always open to revision. It is much like sketching from a distance. Outlines appear, details remain uncertain, yet the form slowly emerges as more observations are gathered. Let us rest for a moment with the mechanism of drawing such cautious conclusions. When a comet is observed, astronomers collect its light, measure how it changes, trace its path across the sky. They apply models, compare results, calculate probabilities. Each step has margins of error. These margins are recorded, not hidden, becoming part of the knowledge itself. This way, the uncertainty is not an obstacle, but an integral part of the process. It tells us how close we are to clarity and how far we may still need to go. Now, before moving further, let us notice the limits. With 3I Atlas, fragmentation took away much of the evidence. With no intact body to study, we remain with incomplete traces. We cannot confirm its exact composition, nor fully reconstruct its shape. We cannot know whether it was typical of interstellar comets or unusual. These unknowns are real, and they matter, but they do not erase what was observed. They remind us instead that our picture is partial, like a page torn from a larger book. The language of traces helps us here. Even with uncertainty, records accumulate. Brightness curves, orbital calculations, spectra with incomplete signatures, all of these are archived. Later, they may be reinterpreted with new methods. In science, traces often gain meaning only after time has passed, when they can be compared against broader patterns. The uncertainty of one comet may be clarified by the certainty of many. In this way, fragments of knowledge become part of a living archive, where even what is missing becomes valuable. We can imagine gently a thought experiment. Step 1. We continue to find interstellar comets, each with incomplete but unique data. Step 2. Patterns emerge. Some share chemical signatures, others fragment in similar ways. Step 3. Over centuries, the collective archive transforms uncertainty into probability, and probability into a quiet form of confidence. The details of 3I Atlas may never be recovered, but its place in the larger story will become clearer. Now we can pause again, to rest with the meaning of this approach. To resist certainty is not to abandon knowledge. It is to accept that knowledge is alive, shifting, unfolding. It teaches us patience, reminds us that the universe does not bend to our pace. The comet is gone, but the traces remain, and in those traces lie both information and humility. A humility that allows us to say, we do not know everything, and that is all right. So we are left with an open ending. The temptation of certainty will always call to us, but the wiser path may be to stay with the unknown, to let it breathe, to see it as possibility rather than failure. 3I Atlas remains partly
A mystery, and perhaps it always will. Yet even in mystery, there is meaning. It is a reminder that not every question has a final answer, and that sometimes the soft rhythm of not knowing is what connects us most deeply to the vastness of the sky. What if the true role of a comet is not only to shine briefly in the night sky, but to carry with it something more lasting, small fragments that may one day become seeds of life? Scientists often describe comets as carriers of molecules, mixtures of ice, dust, and carbon-based compounds. These are the building blocks from which life can emerge under the right conditions. To picture this more simply, we might think of a comet as a frozen pantry, stocked with ingredients that have been preserved since the earliest days of its home system. When sunlight warms it, some of these ingredients are released into space, leaving a trace for us to detect. Now let us gently place this into a larger context. On Earth, we know that life requires certain elements: carbon, hydrogen, oxygen, nitrogen. Comets contain many of these, not as living forms, but as simple compounds. Over long spans of time, impacts from comets may have delivered such material to young planets. In this way, comets are sometimes seen not only as messengers, but as carriers, bringing with them the possibility of chemistry that enriches worlds. This idea is known as panspermia in its broadest form, the suggestion that life's ingredients may travel between systems. It is not proven, but it is a gentle hypothesis, one that rests on the language of traces rather than declarations. We can pause here on the mechanisms that make comets into carriers. When a comet approaches a star, the ice warms and sublimates, changing directly from solid to gas. Along with the gas, tiny grains of dust and molecules escape. These molecules can include organic compounds, which means carbon-based structures like those found in the chemistry of life. We detect them by splitting light into spectra, patterns of colors that reveal which molecules are present. Though the signals are faint, they tell us that comets do indeed hold chemistry of interest. Yet, we must remain cautious. We cannot say that comets carry life itself, only that they carry potential. Absence of clear evidence is not evidence of absence, and we must avoid both overstatement and dismissal. What we know is that comets can store and release molecules, and that such molecules are part of the story of life as we know it. Now let us notice the traces left behind. When comet dust settles in Earth's atmosphere, tiny particles can be collected, sometimes on rooftops, sometimes in polar snow. Inside these grains, researchers have found organic molecules. These findings are archived, cataloged, forming a growing record of what comets bring. In this way, the traces extend beyond the comet's brief appearance in the sky and into a long-lasting archive in laboratories. Even after a comet like 3I Atlas has gone, its possible contributions remain in the language of data and analysis. We may imagine gently a small experiment of thought. Step 1. Comets travel across interstellar space, each carrying its frozen mixture of ices and dust. Step 2.
Some are captured briefly by planetary systems, releasing fragments, perhaps colliding with young planets, perhaps leaving dust in atmospheres. Step 3. Over long spans, these fragments add to the chemistry of worlds, shaping possibilities for future forms. Whether or not life arises, the material is there, seeded by travelers that may have begun their journeys long before. Before moving further, we pause on the humility required here. We cannot confirm that 3I Atlas carried anything more than ice and dust. We cannot trace whether any fragment reached a world where it might matter. What we can say is that the possibility exists, and that this possibility has been part of scientific reflection for decades. It is not a conclusion, but an open space for thought. And so, the comet becomes
both messenger and carrier. A messenger in the sense of orbit and light, a carrier in the sense of chemistry. It does not need to be intentional for its role to matter. Its fragility does not erase its potential. The signal it leaves behind is not a declaration, but an invitation to imagine how matter moves, how seeds might travel, how archives are written not only in books, but in the chemistry of drifting ice. We are left then with a quiet recognition. Perhaps comets like 3I Atlas are reminders that the universe shares, scattering ingredients across time and distance. Not all will take root, but some may, and in that chance lies the soft rhythm of possibility. We let this thought rest, like a seed lying dormant in soil, waiting for conditions it cannot predict, yet holding quietly to the potential it carries. What if the breaking apart of a comet is not an end, but another way of leaving traces, like a book torn into pages that scatter, yet still carry the story? When 3I Atlas fragmented, it seemed to vanish, but in truth it continued in a different form. Dust spread outward, fine particles dissolved into space. Larger fragments drifted along the same path for a while before dispersing. Fragility did not erase it. It only transformed it into something less visible, more diffuse, yet still connected to what it once was. Now we may pause gently with the context. In the scale of the cosmos, fragmentation is common. Comets are held together only loosely, ice binding dust in fragile bonds. Heat from a star or stresses from rotation can break them apart. To us, this may look like disappearance, but in space, nothing truly disappears. It only changes state. The solid becomes vapor, the core becomes dust, and the dust continues, sometimes for millions of years, as streams of particles. These streams are what create meteor showers on Earth when our planet crosses them. So even in disintegration, a comet may continue to touch us. Let us rest for a moment on the mechanisms of how such traces endure. Dust grains released into space can travel along the comet's orbit. Over time, gravity and radiation pressure spread them. Some may enter planetary atmospheres, burning briefly as meteors. Others may drift further, invisible to us, until captured by future worlds. In laboratories, scientists have found micrometeorites, tiny specks of cosmic dust, settled in snow, in ocean sediments, even on rooftops. These are the scattered remains of such processes, fragments of bodies long gone, but still leaving material evidence. Now we should acknowledge limits. With 3I Atlas, no fragments were collected directly. We cannot hold its dust in our hands. What we know comes from brightness fading, from the sudden loss of coherence in its light curve. The evidence is indirect, yet the language of traces is still strong. The rapid decline, the diffuse glow that replaced the nucleus, these are markers of a body dissolving into smaller parts. They are signatures that belong to fragmentation, even if the particles themselves escaped detection. Let us imagine softly a sequence of thought. Step 1. A comet fragments, its dust spreading into space, its body gone. Step 2. Over centuries, particles drift across interstellar space, some captured by magnetic fields, some pulled by distant stars. Step 3. Far in the future, fragments may settle on other planets, or be noticed by other observers, becoming small clues of a visitor long forgotten. In this way, the archive of the comet continues, not as a single body, but as countless tiny records scattered across the universe. Now we pause to reflect on the humility this invites.
What seems like loss is also transformation. We may wish for a whole comet to study, but fragments speak too, only in a quieter language. They remind us that archives need not be solid and intact. Dust is also archive, diffuse but enduring. Each grain holds chemistry. Each particle carries isotopes. Each is a tiny capsule of information from elsewhere. A comet may dissolve, but the record it leaves can persist in ways that outlast the
body itself. And so the breaking of 3I Atlas is not only an ending, it is also an expansion, a scattering of memory into new forms. Some of those forms are visible for only moments, like meteors. Others may last for eons, drifting through space. We do not know which paths its fragments will take, but we can rest in the thought that disappearance does not mean erasure. In the cosmos, even fragility becomes part of endurance, and even loss leaves a trace. What if the smallest particles of a comet are the ones that speak most clearly, leaving faint but enduring messages in places we do not expect? When 3I Atlas broke apart, the body itself dissolved, but the dust that scattered may continue to travel. Some of it may still drift between stars. Some may have joined the fine rain of particles that constantly falls on planets. In this sense, dust is not the absence of a comet, but another form of its memory. Quiet, dispersed, but lasting. Now we may pause with the context. On Earth, scientists have learned to collect micrometeorites, tiny grains that settle from space. They are found on rooftops, in remote ice sheets, even on the floors of the deep ocean. These specks are often smaller than a grain of sand, but under microscopes they reveal textures, crystals, and chemistry that point to their origins. They are like whispers carried over immense distances, unnoticed by most, yet preserving information about the places they came from. The mechanism is simple in outline. As comets travel, they shed dust. When planets pass through these streams, some particles are captured by gravity and fall through atmospheres. They heat briefly, glowing as meteors, or they slow gently and settle unnoticed. On Earth, these particles accumulate slowly, layer by layer, year after year. Ice cores and sediments preserve them as part of the geological archive. To read these layers is to read the sky's history pressed into the ground. But here we must acknowledge the limits. Dust particles are altered when they fall through atmospheres. Some burn up entirely, leaving only fleeting streaks of light. Others change in chemistry from heating. What reaches the ground is therefore incomplete, a filtered sample of the whole. And with 3I Atlas, we cannot know if any of its fragments reached us. The comet's disintegration was distant, its path uncertain. We cannot prove that even a single grain has joined our planet's collection of cosmic dust. Yet, absence of evidence is not evidence of absence. The possibility remains open, resting quietly until further traces are sought. Now let us notice the language of traces more carefully. Dust is its own archive. In laboratories, tiny spheres of melted material tell us of fiery entries through the atmosphere. Unmelted grains preserve fragile compounds that speak of the cold conditions of space. Ratios of isotopes, slightly different forms of the same element, serve as signatures of origin. When cataloged, they form a mosaic, a statistical map of cosmic visitors across time. Each grain is small, but together they tell stories of thousands of comets and asteroids, each leaving behind a fraction of itself. Let us imagine softly a thought experiment. Step 1, 3I Atlas fragments into countless particles, scattering along its hyperbolic path. Step 2, a tiny fraction of this dust enters Earth's atmosphere, unnoticed, drifting down over oceans, mountains, and cities. Step 3, centuries later, researchers sift through ice cores or sediments, isolating particles and identifying unusual isotopes. They realize that one or two may not belong to our solar system at all, but came from interstellar space, fragments of a traveler that passed long ago. In this way, the comet continues to speak long after its body is gone. Before moving on, let us pause to notice what this tells us about endurance. Dust may seem fragile, ephemeral, but in fact it can persist longer than the objects from which it came. A comet dissolves, but dust survives. Dust settles, becomes part of layers, and those layers endure through time. In a way, the smallest fragments are the most faithful messengers. They may carry the memory of chemistry that larger bodies hide, and they may outlast the worlds on which they fall. And so, when we think of 3I Atlas, we need not picture only the glowing body that fragmented and vanished. We can also picture the invisible rain of dust that may still wander, some of it perhaps already part of the quiet archives beneath our feet. The comet's story continues in these tiny grains, dispersed but not erased. What remains is not certainty, but possibility, and in that possibility lies a soft reminder. Even the faintest traces can endure, and even dust can carry memory across the depths of space. What if the warnings we imagine in a comet are less about the comet itself and more about the reflections we project onto it, shaped by our own fears and hopes? When 3I Atlas passed, we wondered whether it carried meaning, whether it was a sign, whether it pointed to futures we have not yet reached. In that wondering, the comet became a surface for our inner questions. It told us not only about itself, but about the way we search for guidance in the skies. Now we may pause gently to place this in context. Across time, human beings have looked upward and seen messages. In ancient chronicles, comets often marked change, sometimes disaster, sometimes renewal. These interpretations were rarely about the comet's chemistry or orbit. They were about us, our anxieties, our uncertainties, our need for direction. Even today, with telescopes and models, the instinct lingers. We still ask not only what the comet is, but what it means for us. Let us rest a moment with the mechanism of this process. The human mind is tuned to patterns. When something rare happens, we notice, and we try to connect it to our lives. A sudden storm, a strange dream, an unusual object in the sky, each can feel significant. This is not error, but part of how we make sense of the world. We weave narrative threads to anchor ourselves in uncertainty. A comet, rare and striking, naturally becomes one of those anchors. Yet here we must acknowledge the limits. The comet itself has no intention. Its orbit is physics, its brightness is chemistry, its fragmentation is stress and heat. To claim it as a deliberate warning is beyond what we can prove. But to notice that we interpret it as such, that we see warning where there may be none, that is part of understanding ourselves. Absence of evidence for meaning is not evidence that meaning cannot be found, but the meaning may lie within us rather than beyond. Now let us notice the language of traces in this inner landscape. The traces of interpretation are not only in scientific archives, but also in cultural ones. Old texts, drawings, and stories show us how comets were read in different times. Some saw them as swords in the sky, others as torches, others as messengers of fate. Today, we have data curves and orbital models, but also news articles, essays, and reflections that show how we responded. These cultural traces are part of the archive, just as important as brightness measurements. They show us not the comet's voice, but our own echoed back. Let us imagine gently a sequence of thought. Step 1. A rare comet appears, and scientists record its properties, while communities wonder about its meaning. Step 2. Interpretations spread, shaped by the fears of the moment, perhaps fear of catastrophe, perhaps hope for connection. Step 3. Long after the comet is gone, what remains are both scientific data and cultural reflections, each telling us something about the era in which the comet was seen. In this way, the warning is not from the comet, but from ourselves, a mirror held up by the sky. Before moving on, we pause with the humility this invites. To see our own hopes and fears projected outward is not failure. It is a reminder that meaning is not only in objects, but also in perception. The comet becomes a partner in reflection, a silent surface upon which we paint our questions. We may never know if it carried a warning from elsewhere, but we can know what our own response reveals. And so, we are left with a gentle recognition. The warnings we imagine may not be cosmic signals at all, but expressions of our own awareness of fragility, of future, of the unknown.
The comet reflects these back to us, not by intention, but by presence. In this reflection lies its quiet gift. We let the thought settle softly. Perhaps the meaning of 3I Atlas is not in what it carried, but in what it stirred within us, reminding us of the futures we fear, the futures we hope for, and the questions that remain open in the silence of the sky. What if the true message of a comet lies not in its sudden brightness, but in the silence that follows after it is gone? When 3I Atlas fragmented and faded, it left behind a long stretch of absence. This absence is not empty, but full of meaning. It reminds us that most of the universe is not marked by noise and spectacle, but by quiet, by spaces where nothing announces itself loudly. In that silence, traces still linger, but they require patience to hear. Now we may pause with the context. The cosmos is vast, and events like interstellar comets are rare. Between one visitor and the next, centuries may pass. For most of that time, the skies remain unchanged, stars fixed, planets moving predictably. The silence is the background, the steady rhythm, against which the unusual stands out. Just as we notice a single drop of rain more clearly on a still day, we notice a comet more deeply against centuries of quiet. Let us rest for a moment with the mechanism of such silences. In astronomy, silence is not only the absence of sound, but the absence of signal. A telescope scans and finds only background light, steady and familiar. When something unusual crosses this field, it creates a disturbance, a trace. Afterward, the silence returns. Yet that return is also important. It frames the event, sets boundaries around it, and allows us to recognize it as distinct. The absence of repetition becomes its own kind of marker. Still, we must acknowledge the limits of this way of reading silence. Sometimes what seems like absence is simply beyond our detection. Our instruments may not be sensitive enough, or our gaze may not be directed in the right place. Just because we do not see another visitor does not mean one has not passed. Absence of evidence, once again, is not evidence of absence. The silence we record may be as much about our own limits as about the universe itself. Now let us notice the language of traces that silence leaves. Observatory logs often show long stretches of routine, nights when nothing unusual appeared. These records may seem empty, but they are not. They mark stability, they define baselines, they remind us what normal looks like. Against this, the rare event takes shape. In cultural memory, too, silences matter. Long periods without comets in the sky were noted in chronicles, just as sudden appearances were. In both science and story, absence leaves its own archive, a quiet frame around presence. We may imagine gently a thought experiment. Step 1. Centuries pass without interstellar visitors, and astronomers collect data of steady stars in repeating cycles. Step 2. Suddenly, another comet appears, faint but distinct, breaking the silence. Step 3. After it departs, the silence resumes, but the records now hold contrast, a rhythm of quiet punctuated by rare notes. Over long spans, these notes may form a pattern, but the spaces between them are just as essential as the events themselves. Before we move on, we can pause on the meaning of these intervals. Silence is not only absence, but space for reflection. It allows us to ask what it means when something does appear. It allows archives to grow slowly, to be filled not only with signals, but with steady baselines. In this way, the gaps become part of the story, not interruptions, but foundations. And so, when we think of 3I Atlas, we do not think only of its brief brightness, but also of the silence before and after. The long stretches of sky without it are part of its message, framing it, shaping our awareness of its rarity. Perhaps the warning is one, lies not in the comet itself, but in the quiet that surrounds it. A reminder that silence is not empty, but full of waiting traces. And that sometimes what we learn comes not from what is present, but from what does not return. We let this thought rest softly, like a pause between heartbeats, carrying meaning precisely because it is quiet. What if the traces of a comet are not only written in data, but also preserved in memory, in archives built by us across centuries? When 3I Atlas appeared, astronomers recorded its path, its brightness, its sudden disintegration. These records joined older archives, shelves filled with centuries of skywatching. In this way, the comet became part of a continuum, a thread woven into the long fabric of human observation. Now we may pause gently to consider the scale. Human memory alone is brief, lasting perhaps a few generations. But written archives, layered across centuries, extend memory far beyond what one person can hold. Ancient astronomers left records on clay tablets, papyrus, and paper. Later, telescopes produced charts and drawings. Today, we keep digital archives, storing data in formats that may last as long as we maintain them. Each step lengthens the memory of the sky. Each step ensures that what was once fleeting can be revisited. Let us rest for a moment with the mechanism of archiving. An observation begins as a point of light, recorded against a grid of stars. Numbers are written: brightness, position, time. These numbers are preserved, compared, and checked. Over decades, they accumulate, forming patterns. A comet that once appeared and vanished remains present in these records. Later researchers can return, reanalyze, find meaning that the first observers could not yet see. In this sense, an archive is not a static box, but a living field, one that grows richer as more is added. Now we must acknowledge the limits. Archives can decay, records can be lost, data can be corrupted. Some ancient comets are known to us only through fragments of chronicles, vague descriptions of hairy stars crossing the night. With 3I Atlas, our data is more precise, but still incomplete. Fragmentation prevented close study. Instruments recorded only part of the story. Our archive holds what we could capture, but not the whole. The gaps are as much a part of the archive as the data itself. Now let us notice the language of traces in these archives. The numbers are not just numbers, they are echoes of the comet's presence. Brightness curves show its life cycle, sharp rises and sudden declines marking its disintegration. Orbital elements show its origin beyond the sun's pole, its hyperbolic departure. These are indirect markers, but enduring ones. They form a fossil of sorts, not in stone, but in data. They remind us that archives are not only collections, but time capsules, preserving moments that otherwise would vanish. Let us imagine gently a thought experiment. Step 1. Centuries from now, scientists look back at the data of 3I Atlas, comparing it with hundreds of other interstellar visitors discovered since. Step 2. They find patterns, similarities in fragmentation, consistencies in chemistry, building a larger story that we cannot yet see. Step 3. The comet's traces, once fragmentary, become part of a narrative that spans millennia, a thread within a tapestry of interstellar movement. What seemed like a fragile, fleeting visitor becomes a long-term participant in the memory of the cosmos. Before moving further, we can pause on what this means for us. By keeping archives, we extend the comet's life in another form. Its body is gone, but its traces remain accessible. Its memory does not depend on fragile human recollection, but on shared records that can outlast us. In this way, the comet reminds us of the importance of preservation, of carrying forward not only answers, but also questions. And so, the quiet message of 3I Atlas may not be in its fleeting glow, but in the fact that it entered our archives at all. Its traces are preserved in layers of data, waiting to be read again.
The comet teaches us that memory is not only a human trait, but also a collective effort, one that transforms the ephemeral into something lasting. We let this thought rest softly, like a page gently closed but not forgotten, part of a book still being written by the skies and by us together. What if the most enduring role of a comet is to remind us that archives are not only human creations, but natural ones too? The Earth itself holds layers of memory, written not in ink, but in sediments, ice, and stone. A comet that passes close, or fragments near us, may leave traces that settle into these archives, becoming part of the planet's long record. In this way, even the briefest visitor can enter a continuity that stretches across millions of years. Now we may pause with the context. Earth is covered with natural layers that accumulate slowly. Ice sheets trap bubbles of ancient air, recording atmospheres from tens of thousands of years ago. Ocean sediments store dust, pollen, volcanic ash, and sometimes even tiny fragments of space material. Rocks contain chemical markers left by impacts or by cosmic dust that has rained down steadily over ages. These are archives not kept deliberately, but faithfully nonetheless. A comet that leaves fragments contributes to these silent records. Let us rest for a moment with the mechanism of this process. When a comet sheds dust or breaks apart, particles drift through space. Some enter Earth's gravity and fall through the atmosphere. Larger pieces burn as meteors, but smaller ones may survive. Over time, they settle onto surfaces where snow, mud, or sand cover them. Layer after layer builds, pressing the particles deeper, locking them into history. Later, scientists extract these layers by drilling into ice or by sampling sediments and analyze their contents. The composition of dust grains can reveal whether they came from within the solar system or perhaps from beyond. This is how comets can leave behind indirect but durable signatures. Yet we must acknowledge the limits. Identifying the origin of a tiny particle is difficult. Most cosmic dust looks similar, and separating interstellar from local sources is challenging. Chemical analysis can help, but results are rarely absolute. We may suspect that certain isotopes or unusual ratios point to an origin outside the solar system, but we cannot always be certain. For 3I Atlas, we have no direct evidence that any of its dust reached Earth. What we have is the possibility recorded as a question rather than a conclusion. Now let us notice the language of traces more carefully. These traces are not only physical particles, but also patterns. If a sudden layer of unusual material appears in ice or rock, it may mark an event, an impact, a passing comet, a burst of cosmic dust. Scientists read these anomalies as signals, comparing them with astronomical records. Sometimes the patterns align, sometimes they remain puzzles. Either way, they are part of the silent archive that connects Earth to the larger cosmos. Let us imagine gently a thought experiment. Step 1. A comet like 3I Atlas fragments in deep space, scattering dust along its path. Step 2. A fraction of this dust drifts into Earth's orbit, settling slowly onto the planet's surface, where it becomes part of sediments or ice. Step 3. Thousands of years later, researchers uncover the layer, analyze the grains, and recognize unusual isotopic patterns that suggest an interstellar origin. What was once a fleeting visitor has become part of Earth's geological memory. Before moving on, we may pause with the humility this invites. We do not always know which layers hold comet dust, nor whether we will recognize it when we find it. Our knowledge is shaped by instruments, by comparisons, by interpretations that may shift over time. But this uncertainty is not emptiness, it is possibility. It keeps the archive open, ready to reveal more as methods improve. And so we are left with a quiet awareness. Even if 3I Atlas has vanished from view, its traces may still be here, hidden in the deep layers of Earth, waiting in silence. Perhaps we will find them, perhaps not. But the
thought itself is calming, that even the briefest visitor can leave behind a whisper, written not in words, but in the language of dust and time. We let this awareness settle softly, like a fine layer of particles drifting down, unnoticed in the moment, but enduring for ages to come. What if the messages we imagine from the cosmos are not carried in words at all, but in patterns that unfold slowly, through numbers, comparisons, and statistics? A single comet may appear unusual, a fleeting exception. But when many events are recorded, when archives thicken, we begin to see rhythms emerge. In this way, the warning or message of a comet like 3I Atlas may not lie in its solitary presence, but in the wider distribution of such visitors over time. Now we may pause with the context. Astronomy is often less about single discoveries and more about accumulation. One star measured is a point, a million stars form a map. One comet observed is a story, thousands reveal categories. Over decades, data builds, and the rare begins to take its place in a larger framework. In this framework, the warning or message of 3I Atlas is not in its solitary presence, but in the wider distribution of such visitors over time. Now we may pause with the context. Astronomy is often less about single discoveries and more about accumulation. One star measured is a point, a million stars form a map. One comet observed is a story, thousands reveal categories. Over decades, data builds, and the rare begins to take its place in a larger framework. In this framework, 3I Atlas becomes one of many dots, valuable not only for what it is, but for what it adds to the pattern. Let us rest for a moment with the mechanism of statistical study. When comets are observed, their orbits, brightness, and chemistry are recorded. Over time, these are gathered into catalogs. By comparing them, scientists see how often comets fragment, how their sizes distribute, how their origins cluster. For interstellar visitors, the statistics are still thin: Oumuamua, 3I Atlas, and perhaps a few candidates. But as surveys grow more sensitive, the numbers will rise. With each addition, uncertainty narrows and patterns begin to speak more clearly. Still, we must acknowledge the limits. 2 visitors in a short span may suggest that interstellar comets are common, or it may simply be coincidence. We cannot know yet. The absence of more detections does not prove they are rare, nor does the appearance of 2 prove they are abundant. Our perspective is shaped by the shortness of our observing history. What feels like a pattern may dissolve as more data arrives. What feels like silence may simply be the limit of our instruments. Now let us notice the language of traces in this statistical sense. The traces here are not dust grains or isotopes, but distributions, curves, and probabilities. A graph of comet frequencies is an archive. A histogram of orbital inclinations is a record. Each data point is a marker, and together they form a shape in the noise. In this shape lies the quiet message of recurrence, of rarity, of what is typical and what is exceptional. We may imagine gently a thought experiment. Step 1. As sky surveys expand, dozens of interstellar comets are found over the next century. Step 2. Researchers compile their properties, noticing that most fragment before reaching the Sun, while a few survive. Step 3. Centuries later, patterns show clear families of interstellar objects, perhaps even pointing back to regions of origin in distant stars. In this way, the message of 3I Atlas is not in itself, but in the role it plays as part of a growing curve. Before moving further, we can pause on how this changes our view. A lone comet feels fragile, a singular event quickly lost. But within statistics, fragility becomes information. The fact that 3I Atlas broke apart adds weight to a frequency. Perhaps interstellar comets are less stable than those bound to our Sun. Or perhaps we simply caught one at the wrong time. The uncertainty remains, but the archive slowly grows. And so the meaning here is quiet and open-ended. 3I Atlas joins not only the physical sky, but also the statistical sky, the one built in records and patterns. Its warning, if we may call it that, lies not in alarm, but in accumulation. A reminder that patience reveals what single moments cannot, that the language of the universe is often statistical, slow, and spread across centuries. We let this realization rest, like dots gathering gradually into a picture, one that will only be seen clearly long after we are gone.
What if a comet like 3I Atlas is not only in its fleeting glow, but in the way it teaches us to imagine futures that have not yet happened? When we watch a body like 3I Atlas arrive, break apart, and depart, we are also rehearsing possibilities. We are practicing the skill of asking, what if more come? What if some carry new chemistry? What if one day a larger one approaches Earth? These are not predictions, but thought experiments, quiet exercises in stretching our imagination forward. Now we may pause with the context. Humanity has always imagined futures through the sky.
Ancient stargazers read omens into constellations, building calendars and warnings from their motions. Today, astronomers use models and simulations, projecting orbits thousands of years ahead. In both cases, the act is the same: to look upward and extend thought into time. A comet like 3I Atlas is not only an event in the present, but also a prompt for imagining long after it has gone. Let us rest for a moment with the mechanism of such foresight. In science, we often use scenarios. A scenario is not a firm prediction, but a structured possibility. We ask what would happen if a comet of a certain size struck Earth, or if many interstellar visitors were discovered in a short span. We calculate the energies, the probabilities, the consequences. The results are ranges, not certainties, but they provide us with a map of what could be. In this way, each comet becomes part of a rehearsal for possible futures. Yet, we must acknowledge the limits. Our imagination is shaped by what we know, and what we know is incomplete. 3I Atlas fragmented before much could be measured. We cannot know its exact structure, nor whether it was typical of interstellar comets. To base futures on incomplete data is always risky. We must hold these thought experiments lightly, remembering that they are exercises, not prophecies. Now, let us notice the language of traces in this kind of thinking. The traces here are not physical fragments, but models, graphs, and probabilities. Archives of simulations stored on servers are themselves records of our attempts to project. A report that calculates the chance of impact, a graph of possible orbital distributions, these are indirect markers, no less real than dust grains or isotopes. They tell us how we imagine the future at a given moment in history. We may imagine gently a sequence of thought. Step 1. A comet appears and is measured, its orbit and brightness recorded. Step 2. Models are built around it, exploring what might happen if others of its kind arrive, if they strike or pass close, if they bring unusual chemistry. Step 3. Centuries later, researchers look back at these models, comparing them with what has actually occurred. In this comparison, they see not only the evolution of the cosmos, but also the evolution of our imagination. Before moving on, we may pause on the humility required here. To imagine is to step into uncertainty. We must accept that many futures we envision will not happen. Yet the act itself is valuable. It stretches awareness, prepares us for possibilities, helps us recognize signals when they come. In this way, a comet becomes not only a visitor, but also a teacher, inviting us to practice seeing further than we otherwise might. And so, the message of 3I Atlas may not lie in what it was, but in what it allowed us to imagine. It carried us forward into futures where comets are more common, where archives are richer, where our understanding is broader. It reminded us that even a fragmenting body can open doors in thought. We let this awareness rest softly, like a rehearsal that may never reach the stage, yet still teaches us how to move when the time comes.
Been taken not simply as natural bodies, but as signals. Now we may pause with the context of history. In ancient records from China, comets were called broom stars, thought to sweep away old orders. In Europe, they were linked with the rise and fall of rulers, with wars, with plagues. In the Islamic Golden Age, astronomers charted them with precision, noting their return, but also interpreting their presence as marks of change. Each culture saw the same sky, but each read it through its own lens of fear, hope, and expectation. The sky was not silent to them, it was a text. Let us rest for a moment with the mechanism of this interpretation. When something rare occurs, it draws attention. A sudden star with a tail seemed impossible to ignore. Without modern physics, explanation came through metaphor. A sword in the heavens could mean conflict. A torch could mean enlightenment or destruction. The comet became a canvas on which societies projected the currents of their own time. In this sense, the meaning was never in the comet itself, but in the human act of interpretation. Yet we must acknowledge limits. These older readings tell us more about the people who made them than about the comets themselves.
The comet did not choose to appear during a war or a famine. Its orbit was indifferent. But to the watchers below, coincidence felt like connection. Absence of scientific knowledge opened a space that imagination filled. This does not make their records less valuable. Instead, it gives us another kind of archive, an archive of cultural traces. Now let us notice the language of these traces. Chronicles, drawings, oral traditions all serve as indirect markers of how comets were seen. A scribe's careful note of a hairy star tells us not only that a comet appeared, but also that it mattered enough to be written down. A painting of a blazing tail over a battlefield preserves an interpretation, not just an observation. Even today, when science offers physical explanations, cultural echoes remain. News reports describe comets as harbingers. Films and stories imagine them as agents of fate. The archive of meaning grows alongside the archive of data. We may imagine gently a thought experiment. Step 1. A comet like 3I Atlas appears in our own time, fragmenting before it reaches the Sun. Step 2. Scientists record spectra, brightness, orbital elements, while communities interpret, some seeing it as fragile beauty, others as omen, others as opportunity. Step 3. Centuries later, future readers look back at our dual records, seeing both our science and our stories, just as we look back at ancient chronicles. In this way, the comet becomes a thread connecting cultures, each adding its own layer of interpretation. Before moving on, we can pause with the humility this brings. Our own interpretations are not final. Just as we see the limits of older ones, future generations may see the limits of ours. Perhaps they will read 3I Atlas differently, with instruments and ideas we cannot imagine. Perhaps they will see patterns invisible to us. In this sense, each interpretation is provisional, a momentary reflection in a much longer flow. And so, the quiet meaning of 3I Atlas may not lie in its chemistry alone, nor in the fears it stirred, but in the continuity of human response. Across time, comets remind us that we are not only observers, but interpreters, weaving stories and statistics together. They remind us that the sky is both physical and cultural, both archive and mirror. We let this thought settle softly, like a page turned slowly in a book that spans millennia, each generation adding its own lines to the story of the heavens. What if the warning we imagine from a comet is not about a single event, but about the fragility of systems, ours included? A comet like 3I Atlas shows us how easily a body can break apart under the stresses of heat, gravity, and rotation. Its disintegration is not a rare exception, but a reminder that structures, even those that have endured for millions of years, can fail suddenly. In this sense, the comet becomes a quiet metaphor for the delicate balance within which we also exist. Now, we may pause with the context. Our planet has seen many moments when balance tipped. Climate shifts, extinctions, volcanic winters, all reminders that systems which feel stable can change. Just as a comet may seem whole until pressure breaks it, so too can ecosystems, societies, and climates appear steady until they reach thresholds. In the scale of cosmic time, both comets and civilizations are fragile, and both leave traces of their changes behind. Let us rest for a moment with the mechanism of fragility in comets. A comet is a mixture of ice, dust, and rock held together loosely. When it approaches a star, sunlight heats the ice, creating jets of gas that can push against its surface. If the rotation is uneven, stresses build, cracks widen, and the comet fragments. The process is not violent in human terms, but slow and inevitable. Fragility is written into the comet's structure from the beginning, waiting only for the right conditions to show itself. Yet we must acknowledge the limits of comparison. Human systems are not comets. Our fragility arises not from ice and dust, but from interconnections: energy, food, technology, climate. Still, the reminder is gentle but real. Stability is not permanent. Absence of collapse today does not mean absence tomorrow. Just as astronomers cannot always predict which comet will fragment, we cannot always predict when pressures on our own systems may grow too large. Now let us notice the language of traces that fragility leaves. In comets, fragmentation appears as sudden dimming, as multiple pieces drifting instead of one, as dust spreading into tails. In human systems, fragility leaves traces in archives, crop records showing decline, layers of ash marking volcanic winters, ice cores recording changes in greenhouse gases. Each archive tells us not only of collapse, but of the processes leading up to it. They are warnings written after the fact, lessons carried forward in data. We may imagine gently a thought experiment. Step 1. A comet travels for millions of years, appearing whole. Step 2. It approaches a star, pressure grows, and it fragments, scattering dust into space. Step 3. Fragments drift for centuries, leaving trails that can be studied long after the body itself is gone. In parallel, we may imagine a society that appears stable, then shifts under pressure, leaving behind archives, texts, ruins, sediments that tell of its fragility. In both cases, what is gone continues to speak through what is left. Before moving further, we may pause with the humility this gives. Fragility is not failure, but part of existence. To endure for any span, whether millions of years in space or centuries on Earth, is already remarkable. The comet's breakage does not erase its long journey. Our own fragilities do not erase our achievements. What they remind us is that endurance requires awareness of limits, and that traces of fragility may be the most enduring archives of all. And so, the message of 3I Atlas may be quiet but profound. Its disintegration showed us how even the oldest travelers can fail, and how failure itself can leave enduring signals. In this, it warns us not with alarm, but with reflection, to notice the fragility of systems, to read the traces they leave, and to remember that impermanence does not mean insignificance. We let this awareness settle gently, like dust drifting in the wake of a comet, fragile yet persistent, a reminder written softly into the silence of space. What if the message of a comet is less about what it brings and more about how it moves, carrying within its orbit a memory of forces we cannot see? A path through space is never random. It is shaped by gravity, by encounters with stars, by the slow pull of galactic tides. In this way, the track of 3I Atlas is itself an archive, written not in dust or ice, but in motion. Each curve, each change of speed, is a record of where it has been and what has touched it. Now,
May pause with the context. In astronomy, an orbit is more than a line on a chart. It is a signature of history. A comet bound to the Sun shows the influence of planets, tugged by Jupiter, bent by Saturn. An interstellar comet, on the other hand, arrives on a hyperbolic path, one that reveals it has traveled from elsewhere, never to return. These paths are clues, faint but durable, telling us not only where an object is going, but where it has come from. Let us rest for a moment with the mechanism of such orbits. Gravity is the sculptor. A star pulls, a planet deflects, a cluster disturbs. Over millions of years, small nudges add up, reshaping trajectories. When we calculate a comet's orbit, we are tracing back these accumulated influences. The line across the sky is like a groove cut slowly by invisible hands, carrying within it the marks of countless encounters. Still, we must acknowledge the limits. To reconstruct a comet's journey across interstellar space is not easy. Distances are vast, uncertainties multiply, and beyond a certain span, the path dissolves into probability. We may say a comet came from the direction of a star, but we cannot prove it passed close. We may calculate its future departure, but only within ranges. The archive of motion is real, but incomplete, blurred by time. Now, let us notice the language of traces in these orbits. Observations give us positions, dots against a field of stars. When connected, they form an arc. From this arc, equations give us orbital elements, eccentricity, inclination, perihelion. These numbers are markers, indirect but precise. They tell us whether a comet is native or interstellar, whether it will return or depart forever. The numbers are not dramatic, yet they are lasting. Long after the body is gone, the equations remain, stored in catalogs, part of the silent memory of celestial mechanics. We may imagine gently a thought experiment. Step 1. 3I Atlas crosses into our solar system, leaving behind a faint trail of observations. Step 2. Astronomers calculate its orbit, recognizing its hyperbolic path, confirming it as interstellar. Step 3. Centuries from now, when the comet is long gone, the numbers remain, allowing future researchers to revisit its motion, to compare it with others, to see patterns in how such visitors move through the galaxy. In this way, its path becomes part of a collective record, connecting one fleeting comet to many others. Before moving further, we may pause with the humility this brings. An orbit may feel like certainty, a clear line drawn across the cosmos. Yet it is never absolute. It is always a best fit, a model resting on measurements with margins. The truth of a comet's past is more complex than any equation can hold. Still, within these uncertainties lies meaning. The path tells us enough to know that 3I Atlas came from beyond and that it will not return. That is already a profound marker. And so, the message of 3I Atlas may lie not in fragments or dust, but in its orbit itself. A curve across the sky that whispers of a long journey, shaped by forces unseen, ending in a brief visit before departing again into silence. Its trajectory is both trace and message, an archive not of words but of motion. We let this thought settle softly, like a line drawn lightly in sand, soon to be smoothed by time but remembered in the record of those who measured it. What if the light of a comet is not only a spectacle for the eye, but also a subtle archive of chemistry, carrying with it information about places we have never reached? When 3I Atlas brightened and then faded, the light it gave off was not uniform. It carried signatures, faint imprints of atoms and molecules scattered across different wavelengths. In that glow, we glimpse the building blocks of distant worlds, even if only for a moment. Now we may pause with the context. Light is often the only messenger we receive from the cosmos. Stars, galaxies, comets, nearly all are known to us first by their light. In astronomy, light is not simply brightness, it is a carrier of fingerprints. When passed through a prism or a spectrograph, it
reveals patterns of lines. Each line corresponds to a substance, hydrogen, oxygen, carbon, and countless others. In this way, we learn not only how bright a comet is, but what it is made of, and perhaps where it came from. Let us rest for a moment with the mechanism of this process. When sunlight strikes a comet, its ice is warm and sublimate, turning directly from solid to gas. This gas glows, and dust reflects light outward. Instruments on Earth and in orbit capture this glow, splitting it into its spectrum. Within the spectrum, absorption and emission lines appear. These lines are the silent words of chemistry, telling us what elements and molecules are present. For 3I Atlas, some of these words were captured before it fragmented, though the record remains incomplete. Yet we must acknowledge the limits. Observations were brief, and the comet was faint. Some signatures are ambiguous, blurred by distance or interference from Earth's atmosphere. We cannot reconstruct its full chemistry with certainty. We cannot know how it compared to Oumuamua or to other interstellar bodies yet to be found. Absence of complete data is not absence of composition, but it leaves us cautious, aware that we have only fragments of a larger story. Now let us notice the language of traces that light leaves. Even a partial spectrum, recorded in observatory logs, is a durable trace. It tells us which molecules were definitely present, which were likely, and which remain unknown. Water, carbon compounds, sometimes unusual isotopes, all can be hinted at. Later, when more interstellar comets are observed, these partial traces can be compared, building a statistical map of chemistry across stars. Light, in this sense, becomes both a momentary messenger and a long-term archive. We may imagine gently a thought experiment. Step 1. 3I Atlas releases gas and dust, glowing faintly in the sun's light. Step 2. Astronomers record its spectrum, noting lines that suggest water and carbon, perhaps other compounds. Step 3. Centuries later, scientists compare these old traces with many newer ones, seeing patterns emerge. Some interstellar comets rich in carbon, others poor, some carrying rare isotopes. In this way, a faint, incomplete spectrum becomes part of a wider language, a shared story across time. Before moving further, we may pause with the humility this brings. To read light is to read a fragile message. It is easy to misinterpret, easy to miss details. Yet the effort itself is meaningful. Light is all we have for many distant objects, and even when faint, it carries knowledge we could gain in no other way. Each spectrum is like a single note in a symphony, incomplete on its own, but essential to the whole. And so the quiet message of 3I Atlas may lie in its light. A glow that carried whispers of chemistry, faint but real, marking it as more than a shadow. Though fragmented, though gone, its light remains in archives, a signal stored in numbers and lines, waiting to be compared, reread, reinterpreted. We let this awareness rest gently, like the afterglow of a fading ember, reminding us that even the most fleeting brightness can leave an enduring trace. What if the most enduring part of a comet is not its visible glow, nor even its fragments of ice and dust, but the patterns it leaves in archives of human thought, patterns that connect science with imagination? When 3I Atlas passed, we measured its orbit, brightness, and sudden breakage. But at the same time, it entered our cultural landscape, shaping metaphors, stories, and quiet reflections about transience and fate. In this way, a comet lives both in data and in memory, two parallel traces that together form its true afterlife. Now we may pause with the context. Across centuries, comets had been both astronomical objects and cultural signs. They have been catalogued by astronomers and painted by artists, written about by poets and modeled by physicists. The same tale that a spectrograph sees as dust and ionized gas, a poet might see as a glowing scar across the heavens. The coexistence of these perspectives is not contradiction, but complement, each adding depth. Comets invite us to hold both, the measurable and the meaningful, the archive of numbers and the archive of imagination. Let us rest for a moment with the mechanism of how such dual archives form. Scientific observation begins with measurement, careful and repeatable. It produces numbers, curves, and charts. Cultural observation begins with impression, with feeling, with the need to connect the sky to human experience. It produces words, images, metaphors. Both are recorded, both enter archives. Over time, these archives overlap. A scientist may be inspired by an ancient chronicle. A writer may draw imagery from new telescope images. The comet, silent itself, becomes a bridge between the two ways of knowing. Yet we must acknowledge the limits. Scientific archives risk losing the human resonance if reduced to numbers alone. Cultural archives risk detaching from the physical reality if they ignore the data. Neither is complete on its own, and both are fragile. Scientific data may decay in obsolete formats. Cultural meanings may fade from memory. The endurance of a comet story lies in the balance, in the way traces are preserved across different domains. Now let us notice the language of traces in these dual archives. In science, the trace is a brightness curve, a spectral line, an orbital calculation. In culture, it is a diary entry describing fear at the sight of a fiery sky, or a painting where a comet hangs over a city. These are indirect markers, but they endure. They allow us to reconstruct not only what the comet was, but also how it was experienced. To read both together is to see the comet as more than a body of ice. It is to see it as part of the shared fabric of human history. We may imagine gently a thought experiment. Step 1. A comet like 3I Atlas appears, and scientists record its trajectory, while communities write about its beauty and fragility. Step 2. Decades later, the data remains in observatory archives, while the reflections remain in literature and art. Step 3. Centuries later, researchers from both science and humanities revisit these records, comparing them, finding connections, perhaps noticing how interpretations changed over time. The comet, long gone, continues to exist through these paired traces, each archive strengthening the other. Before moving further, we may pause with the humility this invites. To preserve a comet's traces requires effort across disciplines. It asks us not to divide the measurable from the meaningful too strictly, but to let them coexist. To see a comet is to measure and to imagine at once. Both are part of what it means to be human under a changing sky. And so, the quiet message of 3I Atlas may lie in its ability to enter multiple archives at once. Its fragments may be scattered in dust, but its story endures in equations and in metaphors, in laboratory logs and in whispered memories of a fading glow. The comet reminds us that knowledge is layered, that traces are many, and that meaning grows in the overlap. We let this awareness settle softly, like two streams flowing together, carrying different waters, yet moving in the same direction toward the ocean of time. What if the true measure of a comet's meaning lies not in its solitary appearance, but in how it joins the long continuity of cosmic visitors? When 3I Atlas crossed briefly into our sight, it became part of a chain that stretches far back and far ahead, linking bodies we have seen with those we have yet to encounter. Each comet is not only itself, but also a marker within a larger sequence, a rhythm unfolding slowly across time. Now we may pause with the context. Our solar system is not closed. It is porous, touched continually by the larger galaxy. Dust drifts in, meteors strike, comets pass. Some are bound, circling the sun for eons, while others, like 3I Atlas, arrive from interstellar space, visiting once before moving on. This interplay is
sudden but constant, even if our awareness of it is recent. The universe is not still. It is an exchange, and comets are one of its messengers. Let us rest for a moment with the mechanism of continuity. Comets travel along paths shaped by stars, by planetary systems, by the tides of the galaxy itself. Each path intersects with others, creating a web of movement. When we observe a comet, we are not only seeing one object, but also touching a pattern of migration that may have begun billions of years ago. The dust it sheds joins interplanetary space, mixing with material from other bodies. In this way, comets are not isolated, but contributors to a larger cycle of exchange. Yet we must acknowledge the limits. Our record of interstellar comets is still thin. Only a handful are known with certainty, and from these we cannot yet define the full pattern. We suspect there are many more, but our instruments may not yet be sensitive enough to find them. The continuity is real, but our view of it is narrow, shaped by short timescales and incomplete archives. The absence of many detections does not mean absence of visitors, only that the language of continuity is still unfolding. Now let us notice the language of traces that continuity leaves. Astronomical catalogs preserve positions, orbits, times of appearance. When viewed alone, each record is a dot, but when placed together, they form a line, a curve, a distribution. Continuity becomes visible in statistics, in recurring ratios, in the slow filling of graphs with data points. Beyond human records, dust from countless comets settles onto Earth, milligram by milligram, creating geological traces of continuity that accumulate unnoticed but persist for millions of years. We may imagine gently a thought experiment. Step 1. Interstellar comets pass by Earth at intervals, some noticed, most unseen, each shedding dust into space. Step 2. Over centuries, astronomers record more of them, building catalogs that reveal patterns in origin, speed, and chemistry. Step 3. Far in the future, these records allow a picture of galactic exchange, showing how stars share material through wandering comets. The continuity that began unseen becomes visible,
a thread woven into the understanding of our place in the galaxy. Before moving further, we may pause with what this means. Continuity humbles us. It reminds us that comets like 3I Atlas are not rare anomalies, but participants in a larger process. Their appearances are brief, but their role in the cosmic cycle is lasting. Each visitor carries memory of its origin and contributes something, however small, to where it passes. To notice this is to shift from thinking of comets as isolated events to seeing them as part of a steady flow. And so, the quiet message of 3I Atlas may be less about its singular story and more about its place in a continuum. Its presence reminds us that we are part of an ongoing exchange, that the galaxy is a system of flows and not a fixed stage. The comet is one note in a melody, still being written, faint but essential. We let this awareness rest softly, like the echo of a rhythm we cannot yet hear fully, but which surrounds us nonetheless, steady and enduring. What if the presence of a comet is less about its own story and more about the perspective it offers us on time itself? A body like 3I Atlas reminds us that while our lives are measured in decades, the journeys of such objects span millions of years, perhaps more. When it appeared briefly in our sky, it was not beginning its path nor ending it. We witnessed only a fraction of a much larger arc, a momentary overlap between its timeline and ours. Now we may pause with the context. Human history, even at its longest, is brief compared to the scales of the cosmos. The oldest civilizations reach back a few thousand years. Written records perhaps 5,000. Comets, by contrast, travel on paths that may have begun before Earth's first forests. They move across expanses that outlast empires, languages, even species. To place ourselves
Beside them is to feel the thinness of our own chronology and the depth of the universes. Let us rest for a moment with the mechanism of cosmic time. Orbits are not days or years, but spans of thousands or millions. Light from distant stars travels for centuries before reaching us. Dust shed by comets may drift for eons before settling. The scale of these processes is vast, yet they unfold with patience, with slowness that feels invisible to us. A comet crossing the inner solar system in months may have traveled for millions of years to arrive. What to us feels sudden is, in its own rhythm, long prepared. Yet we must acknowledge the limits. We cannot reconstruct every detail of 3I Atlas's journey. We can trace its orbit only so far back before uncertainties grow too wide. We cannot know exactly which star system it came from, nor what influences shaped its path. The comet's full timeline is blurred. Our measurements give us a sliver, not the whole. This is the humility of working with cosmic time. We see fragments of vast stories, never the entire span. Now let us notice the language of traces in relation to time. In geology, layers of rock hold markers of past events, impact craters, volcanic ash, ancient dust. In astronomy, traces of time are carried in orbits, in isotopes, in the slow dimming of stars. For comets, their very presence is a trace of time. They endure long journeys, fragment, disperse, and their dust becomes part of new worlds. Each fragment is a marker of age, of passage, of endurance across scales far beyond us. We may imagine gently a thought experiment. Step 1. 3I Atlas leaves its star system millions of years ago, nudged by gravity into interstellar space. Step 2. It drifts silently, crossing voids, passing unseen by countless stars, its journey measured not in days but in epochs. Step 3. For a brief span, it intersects our solar system, fragments, and departs again, continuing its long path, perhaps to wander for millions more years. Our entire record of it, observations, data, reflections, is a thin moment in its vast timeline. Before moving further, we may pause with the humility this brings. To encounter such a traveler is to be reminded that our own lives are short, yet we are capable of noticing, recording, and preserving traces that extend far beyond us. This is how we connect to cosmic time, not by matching its scale, but by placing our small moments carefully within it. Each record we keep is a bridge, linking brief human presence with the immense patience of the universe. And so, the quiet message of 3i Atlas may be about time itself. It tells us that our presence is fleeting, but also that fleeting presences can still matter if they leave traces that endure. The comet will continue long after we are gone, but our record of it is also a mark in the fabric of time, fragile yet lasting. We let this awareness settle softly, like a clock that does not tick in seconds, but in ages, its rhythm slower than ours, yet always ongoing. What if the silence of a comet carries as much meaning as its brightness? When 3i Atlas fragmented and disappeared, it left behind not only data, but also absence. No more light to measure, no nucleus to track, no return to expect. In this absence lies a different kind of message, one that reminds us how endings themselves become archives, how disappearance can also be a form of presence. Now we may pause with the context. The universe is full of absences. Stars die, leaving remnants or fading completely from view. Galaxies collide and dissolve into one another. Even light can be swallowed by black holes, vanishing beyond event horizons. In this vast theater, comets too have their endings, burned away near the sun, shattered by tides, or slowly dispersed into dust that blends with interstellar clouds. Their loss is not dramatic to the cosmos, but to us it is noticeable because it is sudden and final. Let us rest for a moment with the mechanism of disappearance. A comet is fragile by nature. As sunlight heats its surface, ices vaporize, driving out dust and gas. The nucleus loses mass each time it fragments.
Approaches a star. Sometimes, stresses within cause cracks and the body splits apart. The fragments may continue briefly, then crumble further until nothing coherent remains. To an observer, brightness rises, flickers, then fades. What was once a moving star becomes emptiness. This fading is not destruction in the absolute sense, but transformation, the comet becoming part of dust, part of the background. Yet we must acknowledge the limits of how we understand disappearance. We record fading brightness, but we do not always see the final fragments. We infer disintegration from silence in our instruments, from the absence of further detections. The comet may leave behind pieces too faint to notice, trails too dispersed to measure. Our sense of finality is shaped as much by the limits of our observation as by the reality of the comet's fate. Absence is therefore both an event and a perception. Now let us notice the language of traces left by absence. In observation logs, we see sequences ending abruptly, brightness one night, none the next. In archives, gaps appear, marked as no detection. Even these gaps are data, telling us when and where a body ceased to be measurable. In geology, traces of vanished comets may be tiny dust layers in ice cores or sediment, evidence of past showers. Absence itself leaves signatures, faint, indirect, but real. We may imagine, gently, a thought experiment. Step 1. A comet like 3i Atlas brightens as it approaches the sun, then fragments suddenly, fading from sight. Step 2. Astronomers log the last detections, note its silence, and store the absence as part of the record. Step 3. Centuries later, future researchers look back, seeing both the detections and the silences, reconstructing how the comet ended, even though they never saw it directly. In this way, disappearance itself becomes a form of evidence, an archive of absence. Before moving further, we may pause with what this teaches. Disappearance is not emptiness. It is a transformation that leaves behind subtle traces. To pay attention to absences is to read silence as carefully as we read sound, to see fading as part of presence. The comet's ending reminds us that impermanence is not nothingness, but a shift into other forms, other records, other memories. And so, the quiet message of 3i Atlas may lie in how it vanished. Its fading was not the loss of meaning, but the creation of a new kind of archive, absence recorded in data, silence carried forward in memory, fragments joining the interstellar dust.
We let this awareness rest softly, like the echo of a note after it has been played, still lingering in the air, reminding us that endings, too, are part of the story. What if the true message of a comet is not about the comet itself, but about the act of noticing? 3I Atlas was visible for only a short while, then gone. Yet in that brief window, countless hours of observation, calculation, and reflection were devoted to it. The object itself moved on, but the human attention it gathered remained. Perhaps its legacy lies not in fragments of ice, but in the patterns of awareness it created, in the way it shaped our collective gaze toward the sky. Now we may pause with the context. Across history, celestial events have drawn human attention upward. An eclipse, a meteor storm, a comet, each interrupts daily life, even if briefly. These interruptions become moments of alignment, where many eyes focus on the same phenomenon. For 3I Atlas, telescopes across the world turned to follow it, and observers shared their records. Its significance was not only in what it was, but in how many chose to notice it, to interpret it, to wonder. Let us rest for a moment with the mechanism of noticing. To notice is to select from a background. The night sky is full of stars, yet we pick out the one that moves, the one that brightens. Instruments amplify this noticing, turning faint light into measurable data. Archives preserve it, turning fleeting attention into something durable.
The act of noticing transforms a transient visitor into part of our long-term knowledge. Without attention, 3I Atlas would have passed unseen, leaving no trace in human awareness. With attention, it became an object of meaning, connected to stories and reflections that extend beyond its short appearance. Yet we must acknowledge the limits. Attention is selective, shaped by what we expect to see, by what instruments can detect, by what resources we devote to searching. Countless comets pass unnoticed, either too faint or too distant. Our picture of interstellar visitors is shaped as much by the gaps in our noticing as by the successes. Absence of record does not mean absence of presence. It only shows the boundaries of what we chose or were able to observe. Now let us notice the language of traces that noticing leaves. Telescope logs record exact times, coordinates, magnitudes. Journals and databases preserve these numbers. But noticing also leaves less formal traces: news articles, sketches, reflections. These are part of the archive too, even if they are not purely scientific. Together, they show not only what was observed, but how it was received. The comet leaves its signature in data, but also in the very patterns of our attention, scattered across disciplines, cultures, and individuals. We may imagine gently a thought experiment. Step 1. An interstellar comet enters the solar system, faint and almost invisible. Step 2. One or two telescopes happen to catch it, and because of that, many others turn to it, recording and reflecting. Step 3. Centuries later, the comet itself is long gone, but the records remain, not only in numbers, but in the very act of having been noticed. In this sense, the comet's lasting influence lies in how it focused awareness, creating a moment of shared attention that outlives its material presence. Before moving further, we may pause with what this suggests. Noticing is itself a creative act. It transforms the transient into the meaningful. It reminds us that what endures may not be the comet itself, but the awareness it sparked. The act of looking, of caring to measure and reflect, becomes the trace. And so, the quiet message of 3I Atlas may lie not in its nucleus nor in its fragments, but in the human noticing that preserved its brief passage. It reminds us that to observe is to give life beyond disappearance, that what we choose to see becomes part of the long record. We let this awareness settle softly, like the afterimage of a light once seen, fading from the eye, but lingering in memory, showing that even the act of noticing can be its own form of archive. What if the fleeting passage of a comet like 3I Atlas is not an isolated story at all, but part of a longer dialogue between us and the universe? Each visitor, each trace, each absence becomes a quiet sentence in that conversation.
We listen, though often imperfectly. We record, though never completely. And in doing so, we create a bridge between the incomprehensible vastness of cosmic time and the fragile brevity of our own. Now we may pause with the context. Across the last century, astronomy has moved from telescopes of polished glass to instruments that can read invisible wavelengths and store their records in immense digital archives. But even with all this, our direct encounters with interstellar comets are still rare. 2 known with certainty, a few suspected. Against the scale of the galaxy, that is hardly more than silence. And yet, silence itself is a kind of information, reminding us of how much remains hidden. Let us rest for a moment with the mechanism of how knowledge grows. Each detection begins as a chance, a faint light noted, a movement against the background. It becomes observation, then calculation, then interpretation. Over years, many such traces accumulate. Patterns emerge, though never complete. It is like assembling a tapestry from scattered threads, aware that most of the fabric is still missing. The process is not about certainty, but about gradually refining our sense of
possibility, guided always by humility. Yet we must acknowledge the limits. We cannot be sure whether 3I/ATLAS was typical or exceptional. Its fragmentation might have been a common fate for such bodies or an unusual accident. We cannot know whether its chemistry was representative of interstellar material or whether it carried unique fingerprints from a distant system. The absence of proof does not resolve the question either way. Our knowledge will remain partial, and that is its honest condition. Now let us notice the language of traces that remains. The comet left no surviving fragments for us to collect, but it left light, recorded in spectral lines. It left a path, calculated in orbital data. It left reflections, scattered in journals and archives. And perhaps most importantly, it left questions that will linger long after the data itself feels dated. These are the true residues of such encounters, not the comet itself, but the patterns of inquiry it inspires. We may imagine gently a thought experiment. Step 1, 3I/ATLAS passes through, faint and brief, leaving incomplete records. Step 2, decades pass, more interstellar visitors are observed, their traces compared with its own. Step 3, centuries from now, historians of science look back at our early records, seeing not only the data, but also the uncertainties, the careful language of possibility. They read our caution as clearly as our confidence. In that way, the comet continues to speak, not through its body, but through its absence, its memory, its place in the long arc of discovery. Before moving further, we may pause with the humility this brings. The universe does not rush to reveal itself. It offers fragments, glimpses, beginnings without endings. Our role is not to extract final answers, but to participate in the slow accumulation of traces. Each question we leave open is itself a marker, a sign that we were listening, that we were part of the dialogue. And so the quiet message of 3I/ATLAS may be this: to remind us that we are participants, not masters, in the unfolding of cosmic knowledge. Its passing teaches patience, its silence teaches humility, its traces teach continuity. In the scale of the galaxy, our records are fragile, and yet they are enough to mark that we were here, that we noticed, that we added one more line to the conversation. We let this awareness settle softly, like the last note of a song that continues long after we stop hearing it. Knowing that the melody is larger than us, but also knowing that we too belong to it.